Welcome to the video on molecular weight and percent composition. Molecular weight, which is also known as formula unit weight, molar mass, molecular mass, formula weight, and anything that sounds similar, is defined as the mass of 1 mole of a compound. The units will be grams divided by moles. It comes down to a very simple statement. The whole is the sum of the parts. And I find the best way to do this is to set it up as a table. And then the best thing to do is to do it as an example. So what is the molecular weight of C6H12O6? The table gets set up as the number of the specific element times its atomic mass taken from the periodic table equals the product or the part. Add those all up. The sum of the parts gives you the whole or the molecular weight. So here the first element is carbon, and we have 6 of them. The atomic mass of carbon is 12.01 grams per mole, and so that is 72.06 grams per mole. Now we take a look at the hydrogen. There are 12 hydrogens with an atomic mass of 1.008 grams per mole, and that comes out to be 12.10 grams per mole. The oxygen is remaining. We have 6 of them. Its molecular weight is 16 grams per mole, and you do that multiplication, you get the 96 grams per mole. We now have all of the parts, so the whole is the sum of the parts, and you get 180.156 grams per mole, which with correct sig figs is 180.16 grams per mole. The molecular weight of C6H12O6 is 180.16 grams per mole. So that's pretty simple to set up, especially if you follow this methodology, but you don't have to. And so here's one for you to do. What is the molecular weight of calcium acetate? Stop the video, figure it out. I'll give you the answer, then I'll walk you through it. Go. And the answer is 158.17 grams per mole. There are the headings for the table. I've got 1 calcium with its atomic mass to give me this. Now I'm going to distribute the 2 that's outside the parentheses to everything inside the parentheses. So I have 4 carbons times 12.01, and you get this value. 6 hydrogens times its atomic mass is this value, and 4 oxygens times 16 is 64 grams per mole. That's the parts. The whole is the sum of the parts, so I sum it all up. I get 158.168 grams per mole. With correct sig figs, I get 158.17 grams per mole. The whole is the sum of the parts. Now, with this being set up this way, it makes the next part of this video or this lecture easy to set up, and that is on percent composition. Percent composition is the percentage of each element in the compound on a mass basis. We're dealing with a percent. A percent is the part divided by the whole times 100. Here, the part is the contribution of the specific element you're looking at. The whole is the molecular weight. And once you know the percent composition for a compound, no matter the size of the sample, those percentages stay the same. The law of definite proportions. So that leads to the next part, which is if I'm given any of the 2 of percent, part, and whole, I can calculate the third simply by setting up this equation. Once again, example I think works best. What is the percent composition of C6H12O6? Here is my table from before showing the individual parts for carbon, hydrogen, and oxygen, and the total. The part divided by the whole times 100. So for carbon, 72.06, the part divided by 180.16. The whole times 100 is 40%. The mass of any sample of C6H12O6, 40% of that mass is due to the mass of the carbon in that sample. I can do the same thing for hydrogen, the part divided by the whole. Then I could do it for oxygen, the part divided by the whole. So I can say the percent composition of C6H12O6 is 40% carbon, 6.714% hydrogen, and 53.29% oxygen. And that's going to be for any sample with that molecular formula. I can give you a problem like this. You know the percent composition of C6H12O6. You're given a 5-gram sample. What is the mass of the carbon in that 5-gram sample? Once again, stop the video, figure it out, come back, I'll have the answer, and then we'll walk through it. Go. And the answer is 2 grams. What are we given? We know the mass of the sample, or the total sample, is 5 grams. We know the percentage of carbon, which is what we're interested in, is 40%. What are we looking for? What's the unknown? The mass of the carbon in the sample. That's the part. We'll call it X. We know the equation for percentages. Percent equals the part divided by the whole times 100. Substitute what we know in, so 40 equals X divided by 5 times 100. Rearrange so you can solve the sucker, and you come up with 2 grams equals X. So to review this subject, the molecular weight is the mass of 1 mole of the substance. The units will be grams divided by the mole. Synonyms include molar mass, formula unit mass, molecular mass. The whole is the sum of the parts. So then we have percent composition. Here's the equation for any percentage problem. In this case, we're using composition. The part is the contribution of a specific element. The whole is the molecular weight. If you know 2 of the 3 variables, you can calculate the third. And that covers this topic. I thank you for listening, and I look forward to working with you again.